Today's topic is operations on complex numbers. Some of the definitions today include imaginary unit. The imaginary unit, written as I, is the number whose square is -1. So that means I squared is equal to -1, and that all comes from the -1 found under the square root symbol. By definition, the square root of -1 is our imaginary unit I. An imaginary number is the square root of any negative real number. So we will have examples today including the square root of -1 and other negative numbers under the square root. Complex numbers are numbers that can be written in the form a plus bi, where a and b are real numbers. So you can see the portion that's written as a is a real number, and b multiplied by I would be the imaginary unit. When we put these together, that's considered to be a complex number. We're going to work with the sum or difference of complex numbers today. So if you have a plus bi and another complex number, c plus di, you can join those terms according to what the like terms in those are. So since a and c are the real number portions, we can join a and c as one quantity and then combine the imaginary terms, b plus d, multiplied by the imaginary I. In example 1, you can see we have the quantity 2 plus 3i added to the quantity -3 plus 2i. So do be careful when you're working with these problems. Sometimes when people see parentheses, they go too quickly and think it's multiplication. But we have this addition sign in between the quantities, so it really is an addition problem. So by our definitions we just talked about, we could first clear the parentheses and then combine like terms. That means we're going to combine the real number portions together and then look for the imaginary portions and combine them. So our first quantity gives us 2 plus 3i. This addition sign, remember, is distributed to each term in the quantity. So a positive times -3 is still -3, and a +1 times +2i will give us 2i. So 2 minus 3 are the real number portions to combine. That gives us -1. And then +3i and +2i are like terms, giving us +5i. So remember, the form we're looking for is in a plus bi format. That is the real number portion first and then the imaginary number. This is what makes up the complex number. So our answer is -1 plus 5i. In example 2, we have a quantity subtract another quantity. So the first quantity does not have any negative out in front, so we simply release those terms from the parenthesis, but the negative will be distributed to each term in the quantity. So negative times 4 would be -4, and negative times -2i would be +2i. Again, we're looking for like terms. 6 minus 4 would be the real portion, and -3i plus 2i is the imaginary portion. So our final answer in the complex number form a plus bi would be 2 minus I. In example 3, we have the quantity of 9 minus 4i minus 9. So we are just subtracting a single term, not a quantity this time. So we have there isn't a negative in front of the quantity, so it's simply 9 minus 4i and subtraction of 9. I can see that 9 minus 9 will cancel, leaving -4i. So this answer only has an imaginary portion. If we think about a plus bi form, a must be 0. In example 4, we have multiplication. 5i is connected to this quantity with multiplication because of the parentheses. There's no symbol in between 5i and that parenthesis set. So that's how we know it's not addition or subtraction there. So 5i will be multiplied by each term in this quantity. 5i times 4 means we're multiplying 5 times 4 to get 20i. And then 5i multiplied by 7i means we have a negative 35 for the numerical coefficient. And then by definition, I multiplied by I, we apply the exponent rules. So that makes I squared. Now we learned that I squared is equivalent to negative 1. So we really have 20i minus 35 multiplied by negative 1. So don't forget that I squared is equal to negative 1. If I go ahead and multiply that out, I'll have 20i plus 35. Now we're almost at the final answer. We do want to make sure we put this in the complex number format of a plus bi. So that means 35 would actually be written as our first term. And since 20i is positive, we'll add 20i. So now we have it in the standard form for complex numbers. In example 5, we have two quantity sets, and notice there's no plus or minus in between, so this truly is a multiplication problem. With two binomials, we'll simply distribute 3 times each term in the other quantity. That gives us 6 minus 15i, and then we will distribute negative 2i to each term. So a negative times a positive would make minus 4i, and negative 2i times negative 5i would give us positive 10i squared, because I times I will follow our exponent rules. It's actually the product rule. Notice that in the middle we have like terms. So we are really working with this multiplication as if we had our variable x. First term remains 6. Combining our like terms, we would have minus 19i. And for the last term, remember that I squared is equivalent to negative 1. So we'll have to make that substitution. That gives us 6 minus 19i minus 10. Now we have some like terms that have been created. 6 minus 10 would give us negative 4, and then we include the imaginary term, negative 19i. So notice again we have our a plus bi format, and sometimes b is going to be a negative number, and that's why we see subtraction. In our last example, again we have two binomials. They are connected with multiplication. So I'll distribute square root of 3. Notice square roots can be combined with imaginary numbers as well. So hopefully you remember that terms under the radical are multiplied by other terms under the radical. So that first distribution gives us a square root of 9. And then distributing, we would have a term that's a radical multiplied by a term that is not a radical. So that would be minus 2i square roots of 3. So 2 and 3 are not multiplied because they do not appear both under the radical. Next we'll distribute 2i times square root of 3. So that would be positive 2i square roots of 3. And finally 2i multiplied by negative 2i. So that would be subtraction. 2 times 2 would give us 4. I times I, that would be I squared. Notice in the middle, these terms are opposites, so they are actually going to cancel from this problem. Square root of 9 can simplify as 3, and our last term of minus 4 times negative 1, because I squared is equal to negative 1. This gives us 3. And then we have negative 4 times negative 1, that's plus 4. So it looks like 3 plus 4 would give us 7. So the final answer here turns out to be a real number. There's no imaginary portion remaining in the problem because our middle terms canceled, and the last term that involved the imaginary number was I squared. And we know that I squared will be replaced with negative 1. So this final answer is 7.